Good morning, students. Today we are with a new topic, that is chapter number 2 of statistics. The name of the chapter you all know is linear correlation. Now the question arises, sir, what is the meaning of correlation or linear correlation? So first, I would like to start this video lecture with meaning and definition, which is provided on your textbook page number 59 and 60. The definition of correlation. If there are simultaneous changes in the values of two variables due to direct or indirect cause effect, then it is said that there is a correlation between two variables. When correlation is in a linear way, it is called linear correlation. Now, this is the textbook definition, but as per our style, I would like to explain you in the simple way or simple meaning. Now, the important word that repeatedly comes is variable. Now, question arises in our mind first that what is actually variable? So I write here, variable means the value of which changes and which can express in digit also. The value of which changes by person to person or by place to place or by day to day or different aspect which are changes, and it also express in the digit. I would like to put the example of variables before you. Height of a person. See, the different people or different person have different heights which can differ from person to person and which can also numerically represent before us. That is 5'7" height, 6'2" height, 4'7" height. The different heights of different peoples are there and which can also numerically represent. So height is one of the variable. Example of variable. Weight. Different people have different weights. For example, some have weight of 55 kg, some have weight of 65 kg. It differs from person to person. Some have weight of 42 kg or some have 86 kg. So weight is also one of the variable. Marks of a student, percentage or marks. Different students have different marks in mathematics, in science or in social science. They have different percentage in different way. So the marks or percentage is also one of the example of variable. Now friends, here we have to find the relationship between two variables. The definition itself says there are simultaneous changes. Simultaneous changes means when change in one variable, the change in another variable also there. That is called simultaneous change. The change in one variable, the change in other variable also there. Then it is called simultaneous, means similar change. Two variables due to, the reason is direct or indirect cause-effect relationship. Now, what is this cause and effect relationship? See, for the effect of anything, there must be some cause is there behind that. That is called cause and effect relationship. I would like to one example before you so that you can easily understand what is this cause and effect relationship between the two variables. Like the rainfall and yield. Rainfall is one variable, the yield is of another variable. Now, when there is a change in rainfall, there is a change in yield. It means two digits have simultaneous changes. And they also have cause and effect relationship between them. Here, the rainfall is a cause, and my friends, the yield is a effect. When there is a cause, rainfall is there, monsoon is there. After some days, we have rainfall in our city, in our country also. So, rainfall is a cause. When the cause occurs, rainfall occurs, there also occurs or there also effect on yield is there. So, this is called cause and effect relationship between the two variables. I would like to give you another example. Sales of a company and profit of a company. Here the sales is a cause and the profit is effect. When there is a change in the sales, cause effect is there. Simultaneously there is a change in the profit. Effect is also there. So, two variables have simultaneous changes and there is a cause and effect. Then it is said that there is a correlation between two variables. So, two things we can understand from the definition. First, there is a simultaneous changes between the two variables, and there is a cause and effect relationship between two variables. Then the both variables are correlated, or they have correlation between them. And when we put the digits into the graph paper and we plotted it into the graph, and when it is in a linear way, the result comes in a linear way, then it is called linear correlation. The two examples, as I already gave you, rainfall and yield. Rainfall is a cause. Because of rainfall, there is an effect on yield. Cause and effect relationship, simultaneous changes between two variables, they both have correlation. Another example is expenditure and savings. Friends, since we have income, we can do expenditure from that particular income, and we can also do savings from that income. See, if our expenditure is more, one variable, that is expenditure is more, then definitely our savings is less. So here expenditure is a cause and the savings is a effect. When we do more and more expenditure, we have less savings. So both have simultaneous changes. Here expenditure and savings also have simultaneous changes, and there is a cause and effect relationship between two variables, that is expenditure and savings. So they both are in correlation. So I repeat again, simple way, when between two variables there is a simultaneous changes and they have cause and effect relationship with each other, then they both have in correlation, and when they are in linear way, it is called linear correlation. Now we move towards the board weightage of correlation. Here I put the board weightage of marks of this chapter, that is linear correlation. Section, question and marks. In section A, they ask one question to us and it provides you 1 mark. In section B, that is VSQ, very short questions, one question they ask and it provides you 1 mark. Section C, they ask one question and it provides you 2 marks. Section D, one question they ask, it provides you 3 marks. And section F, they ask one question and it provides you 5 marks. The total weightage of this chapter is 12 marks. They ask 5 questions and it provides you 12 marks in board examination. Remember friends, the first chapter, that is index number, also have 12 marks weightage. The first part of statistics, all the 4 chapters have similar, that is 12 marks weightage. 12, 12, 12, 12. Total weightage of first part is 48 marks. So linear correlation gives you 12 marks, and I am quite confident that you all are able to achieve all the full 12 marks. Now we move towards our next topic, that is types of correlation. There are major 2 types of correlation: positive correlation and negative correlation. On the basis of these 2 main parts, there are another 3 parts of that. Like in positive correlation, perfect positive correlation is also there, and partial positive correlation is also there. In negative correlation, perfect negative correlation is there, and partial negative correlation is also there. And fifth and last is lack of correlation, or we can say no correlation. So first I would like to explain you the main 2 types of correlation, which is also provided on your textbook, page number 60. Positive correlation and negative correlation. When both the correlated variables have the changes in the same direction, it means if one variable increases, similarly the another variable also increases, and if one variable decreases, then similarly the another variable also decreases. So changes between 2 correlated variables are in the same direction, then this type of correlation is called positive correlation. I would like to give you 2-3 examples of it. First example is price and supply. As we all studied in the economics standard 11, the law of supply. When price increases, the supply also increases, and when price reduces, the supply also reduces. It means the change in one variable, that is change in price, the similar direction change in the value of supply. Price increases, supply also increases, because traders are willing to sell their product at maximum price. And if price reduces, then supply also reduces. So the change between 2 variables are in same direction, then they have positive correlation with each other. Another example, sale of a company and profit of a company. Friends, if the sales increases, then the profit also increases, and if the sales reduces, then profit also reduces. Change between 2 correlated variables in the same or similar direction. Increase in sales, increase in profit. Decrease in sales, decrease in profit. Then they both have positive correlation with each other. Third example, number of vehicles and number of accidents on the road. It is clear that if the number of vehicles are more, then the chances of number of accidents are also more. If the number of vehicles are less, then there is a chance of number of accidents are also less. 2 correlated variables, changes in same direction, positive correlation. Second part is negative correlation. When between 2 correlated variables the changes are there, but not in similar direction. The direction is changed. The direction is in opposite way or inverse way. For example, when one variable increases, the another variable decreases. Or another variable increases, then one variable decreases. When two correlated variables have changes but in opposite direction, then such a relationship or such a type of correlation is called negative correlation. Remember friends, in positive, similar direction change, in negative correlation, opposite direction change. I would like to give you 2-3 examples of it, like price and demand. As we all studied in standard 11th economics, the law of demand, when other things being equal, the price of a commodity increases, the demand of a commodity decreases. And if the price of a commodity decreases or reduces, then the quantity of that particular product is increases. There is an inverse relationship or opposite direction change between price and demand. So they both have negative correlation, because price increases, demand decreases. Price decreases, demand increases. So they both have negative correlation. Another example is expenditure and savings. Suppose expenditure from our income increases, then savings itself decreases. And if expenditure decreases or reduces, then savings itself increases. So both the correlated variables, expenditure and savings, but they have opposite direction change, then they are in negative correlation position. One increase, another decrease. One decrease, another increase. Third example, day temperature and sale of woolen clothes in winter. Suppose the day temperature of a day is lower, become lower and lower, then sale of woolen clothes increases. The temperature goes in lower way, reduces, then the sale of woolen cloth increases. If temperature goes up, then sale of woolen cloth reduces or decreases. So this both have opposite direction change, so they both have negative correlation with each other. In this chapter, after studying the types of correlation, we have to move towards the different method of linear correlation. We have in our syllabus of standard 12, there are 3 main methods of linear correlation. First method, scatter diagram method. Second method, method of Karl-Pearson. And third method, that is Professor Spearman's rank correlation method. 3 methods we have to study. The chapter is mainly based on the formulas. So I am confident that you can easily able to understand the definition or concept of correlation. If anybody asks you, then you can easily able to explain before them. Then easily you can explain that when there is a change, simultaneous change between 2 variables, and there is a cause or effect relationship between the 2 variables, then they both have correlation, and when it is in a linear way, it is called linear correlation. Thanks.